This is chapter 3, lesson 3, on page 163. All right. This lesson is all about quadratic functions. We've talked about analyzing graphs. So what do you know? What do you know already about a quadratic function? Go. It's what, Will? It's a parabola. You know the shape of it is a parabola. What else do you know? It's a second degree equation. If it's a parabola, it only has a max or a min. It's only either increasing then decreasing or decreasing then increasing, right? It has no points of inflection because it doesn't change directions. And it's only either concave up or concave down. All right? Now, with a quadratic function, we know that how many possible x-intercepts does it have? Hannah? Up to 2. So it can have 0 x-intercepts. When it has 0 x-intercepts, and I solve for the value of x, what do I end up with? Imaginary solutions, plus and minus something I. So I have complex solutions if there are no x-intercepts. I can have one x-intercept where it comes down, it touches the x-axis and goes back. That looks something like this. This is when it's just going to touch the x-axis at -2 and return. It will not cross the x-axis. Or I can have 2 x-intercepts. How many y-intercepts do I have? 1 and only 1. In fact, that is true of every function. If it is a function, there will be 1 and only 1 y-intercept. All right, so I have 0, 1, or 2 x-intercepts. I have 1 y-intercept. In order to graph a parabola, what is one of the most important points to graph it? Yes, Hannah? The vertex. So your vertex is either going to be your min or your max. Got it? And there are 3 different forms for the parabola that are functions. There's actually another one, but it's not a function. It's where y is squared and x is to the first power. We will learn that later on. But there are 3 different forms of the function, of a quadratic function, that we are going to learn today. All right. So last year, we did work the polynomial. So that's just ax squared plus bx plus c equals 0. Or I could have said equals f of x, or I could have said equals y, right? Literally, when we're solving them, we're substituting 0 in for y. That's the polynomial, right? To graph them last year, what did we do with the polynomial form? Do you remember? We completed the square to get it to what's called the transformation form. And so the transformation form is ax minus h squared plus k. We rarely had an a out here. To arrive at the x-intercept form, we took the polynomial form and we could factor it. You didn't realize you were doing it. We asked the question, what are multiples of a times c such that we add them and we get the b value, such that we end up with a x minus some value, x minus some value. Now maybe s and t were both negative, so that would have made it x, maybe x minus 2 times x plus 3. All right, but here's the standard form for all three. All right, and I wrote out here, this is that's the formulas, that's the equations, that's the f of x. All right, we are accustomed to the polynomial. So we're going to talk about all of these and then we're going to work through the examples, all right? We need to know the x-intercepts. We need to know, I'm going to do the y-intercepts next. And then we need to know what the vertex is. If we have those 3 points, we can graph any quadratic, all right? All right, so with the polynomial, how do we find the x-intercepts? There's a couple of ways. How do we find, if I have a polynomial, what are my options for finding the x-intercepts?
You can factor and then take the opposite of each.
I could factor it. That would be one. I could factor it, right?
Could you use the quadratic too?
Or I could use the quadratic. That's what quadratic formula. So x equals what? The opposite of b plus or minus the square root.
B squared minus 4ac.
All right, that's how I'm going to find my x-intercepts. That should be your default. When I have a quadratic, the default is, when in polynomial form, the default is the quadratic formula. All right? What is always going to be my y-intercept in the polynomial form? I've already given you the answers. My constant is always going to be where it crosses the y-axis. So, why? Why is that the case? Well, yes, because when x is 0, these first two terms are 0. Got it? So that y equals 0 plus 0 plus c. All right, so my y-intercept is always going to be the c value. I'm trying to see if that's how I wrote it. Is that how I wrote it? Yes. So the x-intercept is when y equals 0, right? And the y-intercept is when x equals 0. For us last year, the way we found the vertex is we completed the square and put it in transformation form. But I did tell you another method for solving for the vertex. And if you look at the quadratic formula, you can see two parts. What's under the radical, what's not under the radical. Okay, what's under the radical is the discriminant. I think we've already talked about this, right? What does the discriminant tell me? How many and what types of x-intercepts or solutions there are. It tells me, is there one? If this is 0, there's 1. If this is a positive number, there are 2. If this is a negative number, there are 0 because it's imaginary. So this discriminates how many and what types of solutions we have. The other part, negative b over 2a, gives me the vertex. So that my x value is going to be negative 2, b over 2a. Then how do I find my y value? Well, I plug this number into the equation and I solve for it. So it's f of negative b over 2a. Right? I'm plugging this value into the function to get the y value. Right? We've talked a lot about this, right? If negative b over 2a, suppose negative b over 2a is 3. Let's just suppose that. Then my y value is going to be this. That's what this is notating. Whatever solution I get for x, that's what I'm plugging in to the equation to solve for the y value. All right, we're going to work through some of these. All right. For the transformation form, the vertex is the easiest. What's the vertex? It's your HK values. It's just your HK. Remember we said opposite same? Because this is a negative and that's a positive. All right? So it's literally your HK values is your vertex. Your vertex is given. All right? What about your y-intercepts? How can I know my y-intercepts? Okay, for transformation, there is this formula. It's AH squared plus K. Here's what I tell you to do. Make X equal to 0. That's what I would do. Plug 0 in there and solve. You don't have to memorize an equation. Just make X 0, then solve for Y. That's the easiest way to solve that, even though I've given you the formula on this sheet of paper. All right, there's also a formula for the x-intercept, but you know what I say? Set it equal to 0. Make y equal to 0. So you're going to set that equal to 0, right? Then you subtract the k value. Follow this logic. Subtract the k value on both sides. Divide by the a. Square root both sides. So it's plus and minus. And then add this value. Right? We worked these in the previous chapter or lesson. And then solve for x equals the number. Or you can memorize the formulas on that sheet, right? All right. For the x-intercept, it's like they're already factored, right? So we know what our x-intercepts are. It's this s and this t, the opposite of it, right? So literally, it is the value of s and t, because if it's x minus 2 times x minus 3, s is 2, s is not negative 2. You got it? It's literally the s and the t. So in x-intercept form, if I give that to you and ask for the x-intercepts, it would be a sad day if you got that wrong, huh? Yes, it would be. Okay, the vertex is such an interesting concept because it's literally the midpoint of s and t. Why is the x value, it's the midpoint, it's s plus t, the vertex, s plus t over 2. Why? Let's think about the reasoning. Let's just say that's negative 1, and let's say that is 3. It's a bad negative 1, I know. Okay, why could I add those and divide by 2 and find the x coordinate of the vertex? what is true about every parabola? It has an, yes?
I forgot what it's called, but it's like a line that splits it right down the middle.
Yes, an axis of symmetry. It has an axis of symmetry. So this axis of symmetry has to be right in between those two coordinate points. And the axis of symmetry always goes through the vertex. So I can take the average of the x-intercepts and find the x-coordinate of the vertex. Now, how am I going to find the y-coordinate? If I have the x-coordinate, then plugging it in and solving for y. So I'm going to plug in whatever that value is into the function and solve for the y-coordinate.
When you have the f of something, what are you plugging that in again? Where?
This is what I'm plugging in for x. To solve
For what?
for y. The whole thing is y. What's inside the parentheses is what I'm plugging in for x. All right? Now, how do I get the y-intercept? Well, how do you think I would get the y-intercept? I'd set x equal to 0. Or you can multiply a times s times t. Because wouldn't that be your constant? Right? If the equation were 3 times x minus 2 times x minus 1, my constant is going to be 3 times negative 2 times negative 1. That's going to be the only constant. Yes?
When you say that you're gonna plug x in for y, are you gonna like distribute?
Well, this is going to be a number.
I meant like the equation. Are you plugging it when it's in like the standard form?
I can plug it in here. Like when x equals 0.
Okay.
I would say 3 times 0 minus 2 times 0 minus 1, which is the same thing as a times s times t. Yes.
Where did you get the 3 from?
Okay, I just made this
Made
up.
that up? Okay.
Just made this up.
So that would be given, or we would solve for that? Solve for
It
that?
would either be given or you'd have to figure it out by factoring. Okay, I also gave you on the sheet of paper how to change forms. I've given you some, so from polynomial to transformation, I'm completing the square. From polynomial to x-intercept, I'm factoring. But look, on this sheet of paper, if I want to go from transformational back to polynomial, if I want to go this direction, I'm just multiplying and simplifying. Got it? Also here, I'm just multiplying and simplifying. I'm just multiplying and simplify. Multiply and simplify. All right? So that's A, transformational to polynomial, and and C. That's A and C. Multiplying and distributing, simplifying. Now, if I'm going from polynomial to the x-intercept, I may have to first factor out something that's in every term. Can I erase some of this? So that would be the case, like if I have 2x squared plus 4x plus 6, what's going to be my A value? 2, because I can take a 2 out of every term. You get it? That's when we're going to have an A value. So I may have to first factor out an A value and then ask myself of the resultant polynomial, what are factors of A times C such that I add them and get the B value, all right? And to get from here to here, we have to complete the square. All right, so you're gonna have to go back and forth to both of them. To get to polynomials the easiest. From any of the forms, you're just gonna multiply, distribute, simplify. But to get from polynomial this direction is a little harder. So here's what I would never do. I would never go from x-intercept to transformational. Yeah, it's kind of icky, isn't it? So I would always go, and I would never go transformational to x-intercept. I'm always going back to polynomial, then going. Got it? That's just what I would do. All right, now let's walk through the examples. Okay, example 1. I'm going to erase what's on the board. I already told y'all I started playlists, right? Did I tell y'all I have playlists?
Good job.
Okay, I didn't tell y'all. So there's a playlist and it's named Precalculus. As we walk through, I know, so unoriginal. As we walk through lessons, here's my goal, to move my lessons to that playlist. Okay? That's the goal. So what I'm recording now will go, it'll be in, can y'all see my, I think y'all can see my playlist.
There's like a little tab.
There's a tab. Okay, so if you go to playlist and then click Precalculus, some videos are already in there. All right, look at example 1.
Are videos from past years in there?
As we go through the lessons, I'm moving them there. I think they stay in both locations, actually.
They do.
I don't know. But I'm adding them, saving them to the playlist. Okay, now, example 1. All right, here we have the function. All right, we want to find the vertex, the x-intercept, and the y-intercept. And then sketch the graph. All right, so we already know the vertex. What's the vertex? 3, -4. So I haven't said this. How do I know if it opens up or down?
Oh.
How do I know? Well,
If the lead coefficient is negative.
if this 2 is plus or negative. If it's positive, it opens up. If it's negative, it opens down. Got it? All right, so let's go ahead and graph that vertex. All right. What are the x-intercepts? Shall we use the formula?
Yeah.
I mean, I don't really like the formula. How about let's not? Let's work it the way that I would, yes.
Are there any instances where we have to use them? And we can't use the plugging in 0?
I can't think of one time that you would ever. Because the formula for the x-intercepts gives you the h, the k, and the a value. So if I gave it to you in words, you could write the formula. Right? All right, so I would make, when the x-intercepts, when what? Y is 0. So set it equal to 0. I'm going to go up. I'm going up. 2 times x minus 3 squared minus 4 equals 0. Add 4. Can we add 4 and divide by 2 at the same time? X minus 3 squared equals 4 over 2. Got it? Which is 2. Then I take the square root of both sides. So we have x minus 3 equals plus minus the square root of 2. So x equals 3 plus and minus square root of 2. All right, so somebody tell me what that is as a decimal. What's plus as a decimal? Somebody do minus.
I got plus.
Okay, somebody do minus.
Plus is 4.41.
Okay, like about here.
4, 2, 1, 3, 5.
And what is minus? 1.6. 1.6. I know it was about 1.6. All right. So now I have the y-intercepts. Wow, the x-intercepts are 3 plus minus square root of 2, and you'd have to know the decimals. All right, the y-intercept is when x is 0. So it's 2 times 0 minus 3 squared minus 4. That's 2 times negative 3 squared minus 4. Negative 3 squared is? 9 times 2? 18 minus 4. So it's 14. So it's going to be way up here. We'll put 14 up here. All right. I have my axis of symmetry, right? Right? And I can go, if that's 3 there, I can go 3 over here, right? So, got it? We can graph it.
Okay, wait. I have a question.
Yes.
How did you get the other dot?
Okay. Somebody explain, how did I get this dot?
You.
Jaden.
The axis of symmetry.
I use the axis of symmetry
Oh.
at the vertex. So if this is 3 units from the axis of symmetry, then there's another one over here, 3 units from the axis of symmetry. Got it? Everybody got it? Okay, that's transformational form and finding the information. Example 2 is polynomial form. All right, so we're going to use polynomial form and find the information. All right, so we have f of x equals x squared plus 2x plus 3. And it says find the vertex, the x-intercepts, the y-intercepts. All right, let's start with the y-intercept. What is it? 3. All right, so we can graph that. We know it crosses the y-axis at 3. All right, let's find the vertex. What is it?
Would be negative b over 2a.
And what is that?
That would be 2, or negative
Opposite
2
of 2 over.
over 2 times 1.
Yes.
That'd be 2.
So this is negative 1. Okay, now how do I find the y coordinate? I'm plugging negative 1. Okay, so negative 1 squared is 1. Plus 2 times negative 1 is negative 2 plus 3. What is that? 2. Right? What did I do? F of negative 1. All right, so that's negative 1. Here's my vertex.
Wouldn't it be negative 1 on the x-axis?
Yes. Yes.
And
Negative
2.
1, 2. Wow, that's so close. Yes, thank you. I'm feeling a little dyslexic. Thank you. Thank you. All right, negative 1, 2. All right. I did it wrong. All right, it's okay. How am I going to find the x? What? Well, in the polynomial, I'm using the quadratic formula for. You see what I did? Do you see what I did, Mackenzie? All right, quadratic. X equals the opposite of b. Let's write the numbers. -2 plus minus the square root of 2 squared, which is 4, minus 4 times a times c all over 2a. Are we going to have x-intercepts?
Wait.
No.
Why?
Square root's negative.
Because this is an imaginary number. So none. None. No x-intercepts. So how do I plot another point? I look at my axis of symmetry, right? I look at the y-intercept. I go over 1. Yes.
This might be like a dumb question, but how do you find the x?
It's always the x value of the vertex.
Okay. Sorry.
The vertical line at the x value of the vertex. It's a great question.
Sorry.
Great question. All right, example 3. The x-intercept form. Yes. What, Mackenzie?
So there's no x's?
No x-intercepts.
And we know that because x equals.
An imaginary number.
Oh, okay.
What's under the radical is going to be negative, which gives us an imaginary number. All right, now look at x-intercepts. All right, you want the vertex, you want the x-intercepts, you want the y-intercepts. What do you already know?
X-intercepts.
What are the x-intercepts?
4, negative 2.
4 and -2. 4 and -2. All right. Can we figure out the x value of the vertex? What do you think, Michael?
Wouldn't it just be 1? Or it'd be, you'd add the
yeah,
two.
yeah, yes.
You'd add the 2 together and then divide by 2.
Yeah. 4 plus -2
2 divided by 2 would be 1.
divided by 2 is 1. It's the midpoint.
Wait.
All right. So that's the x value. Then we plug this into here to get the y value. All right, so it's -1/2 times 1 minus 4 is -3. 1 plus 2 is 3. So we know it's going to be positive. Positive what? Positive 9/2. So in my mind, it's 4 halves. Does this open up or down? It opens down. That is correct. So this is 1, 2, 3, 4, 5. So it's about here. Makes sense because that's negative. All right, how are we going to get the y?
Plug in 0 first.
Plug in 0. You can. Or it's -1/2 times 4 times -2, but let's just make it -1/2. When x is 0, that's -4. When x is 0, that's +2. You see, I just plugged in 0 for x. So we know it's going to be positive. What is it going to be? 4. So 4, if this is my x, I don't really need another one, right? I can just go zoom, zoom. I could have plotted a point over here, right? Through my axis of symmetry. Yes, ma'am.
And you know it's negative because the negative 1/2.
I know it
It goes-
opens
it goes
down
down,
because
right.
of the negative 1/2. That is exactly correct. Yes.
Y is just 4
Yes.
or 0.
Yes. All right. Let's look at example 4. All right, how do we change to polynomial and to x-intercept? All right, we're going to work A and C of example 4. All right, so A is 0.4 times x minus 3 squared plus 2. What is that form? What form is this? Transformational. So this is transformational. Let's go to polynomial. I'm just going to do the math. I'm going to distribute and simplify. First, I'm going to work inside the parentheses. So it's 0.4. What's x minus 3 squared?
Minus.
Got it? Distribute the 0.4. So we have 0.4x squared minus, I think that's 2.4x plus 3.6 plus 2. So we combine our like terms. 0.4x squared minus 2.4x plus 5.6. All right, how would we work C?
Do you factor?
C, what form is this one?
Oh, I thought we had to do it in an x-intercept too.
We're going to do that in a minute. We're going to go from this one to x-intercept in just a minute. Yeah, it's not going to be pretty, but we're going to do it because we can. Okay, what form is this? X-intercept. What are we going to do to get it to polynomial? Just multiply it out. All right, so we're going to multiply the binomials. And what are the binomials multiplied? Come on. Minus 2x minus 8. So it's negative 2x squared plus 4x plus 16. Okay, can I factor 0.4 out of both of these? All of these? Everybody divide it. Go. Somebody divide 2.4 divided by 0.4 and 5.6 divided by 0.4.
2.4 divided by 0.4 is 6.
So we have x squared minus 6x. What's 5.6 divided by 0.4?
14.
It's 14. So plus 14, is that correct? Okay. Are there factors of 14 so that we add them and get negative 6? No. Is there another way I can find the x-intercepts? Quadratic, that's right. All right, so x equals 6 plus minus the square root, 6 squared, 36, minus 4 times a. What's 4 times 14?
56.
Okay, there's no x-intercepts.
You don't put it over 2a?
Well, it doesn't matter. There's no x-intercepts. Can I go to x-intercept method form
No.
if there are no x-intercepts? I can't. All right, can we, for B, let's do B and move it to x-intercept. All right, I should have looked at that first. You can't put A in x-intercept form if there are no x-intercepts. All right, so let's look at B. 3x squared minus 3.9x minus 43.2. All right, first thing I'm going to do is divide every term by 3, so I need your help. That's going to be my A value. Somebody do the division for me. I can do the first one. I can do the second one. I could do the third one. Is that right?
How did you do that?
Yes, you're correct.
I factored out a 3. Okay, now I'm going to do the quadratic. I know it's going to work because this is a negative. All right, so it's going to be 1.3 plus minus the square root. I need somebody to do this for me. 1.3 squared minus 4 times 1 times negative 14.4. So this is going to be a positive. All over 2 times 1. So somebody do the plus of this, somebody do the minus of this for me. What's the plus? Yes.
Plus is
Four.
9.
Plus is what?
4.5.
Plus or negative? Positive or negative?
Positive.
It's positive? That is correct. X minus 4.5. It's positive.
The subtraction is negative 6.4.
So that'd be minus a negative, which is plus. The book says 3.2. 3.2. So you should have gotten x equals 4.5 and negative 3.2. Okay, order of operations is probably why you got an error. Okay, I want to do one more, guys. Oh my goodness gracious. I want to do example 6. All right. I feel like I'm running low on time. I am, but we're gonna make it, maybe. We're gonna try. Okay. Example 6. Okay, so this is a peek into calculus. We're gonna find the maximum area for perimeter. All right, they wanna maximize the area for a field, a rectangular field. And they're going to enclose it with 3,000 feet of fence. So that 3,000 feet of fence, I know, is the perimeter, right? So if we draw the rectangle and make that x and y, then I know that 2x plus 2y has got to equal the 3,000, right? And then I know that the area is going to equal x times y, right? This is what I want to maximize, is the area. That's what I want to maximize. I want it to be the biggest, okay? It's going to look like a parabola. All right, so I'm going to solve this equation for y and substitute y in here so that I only have x's. Does that make sense? First, I'm going to divide everything by 2. When I divide every term by 2, I end up with this. I'm solving for y because I want to substitute y in so that y equals 1,500 minus x. So that the area is x times 1500 minus x. So that the area is going to be negative x squared plus 1500x. You agree? Okay, the maximum, what does this look like? Looks like a parabola that opens down. That is correct. That is exactly correct. So it's going to be like this, right? The maximum area is going to be right here at the vertex.
Whoa.
So, could I do that? Of course I can add 0 to anything. Okay, so the maximum amount is always going to be at the vertex. What if I had an equation and let's say it had to do with cost and I wanted the smallest cost. When is my cost the lowest? It's going to be the minimum. That's right. So this max and min that vertex is a very practical concept. All right? So can I find the vertex from this?
Yes.
What's the vertex?
Um,
What form is this?
Polynomial.
Polynomial. What's the x value?
Fact.
No, I want the vertex.
so why
Oh,
was
the
it-
first part of the quadratic.
First part of the quadratic. Opposite of
To
b all over 2 times a.
X equals that?
750.
The x coordinate of the vertex. The x coordinate of the vertex. What is that? 750?
750. I have never struggled.
Okay. Can I figure out the y coordinate?
Yes.
Okay. I'm sure they've done the math here. They just plugged it in. When x is 750, wait, y is also 750.
It's a square?
It's actually a square. So what are the dimensions of the field?
750.
That's the dimensions such that the area is maximized.